लेते हैं molarity. Actually, molarity is number of moles of the solute dissolved in molarity is the number of moles of the solute dissolved in per liter of the solution. So a liter of the solution, but the molality is the number of moles of solute dissolved in per kg of the solvents. Actually, for molarity and molality, equal amount of solute is used. Equal amount of solute is used. But molality is something else and molarity is something else. Actually, when we have to prepare the molar solution, molarity, then the solution is measured in decimeter cube and volume. So it should be equal to 1 liter. The volume of solution should be equal to 1 liter. But in case of molality, the solution the solvent is measured in kilograms and the solvent should be 1 kilogram. The amount should be 1 kilogram of the solvent. So that should be molality. And from this molarity and molality, there is trigonometric calculations as molarity is the number of moles of solute per liter of the solution. As some problem is given here, what mass of potassium iodide is required to make 500 ml of the 2.80 molar potassium iodide solution. In this condition, molarity should be equal to mass of solute divided by molar mass of solute multiplied by 1 over volume of solution in DM3. So we can find the mass and we can find the molarity and we can find the volume of the solution as well. So it should be calculated as mentioned. So the volume, moles, and grams. So that relationship here. Volume should be 500, but 500 divided by 1000 because we have to convert it into liter. Then it should be 0.5. Then next one is moles, and moles means 2.81 divided by 1, that is a molarity, and in grams. So it should be 166 grams of potassium iodide that can be calculated from here, and that grams overall it should be 2 molar, so it should be 230 to 2.8 molar, so it should be 232 grams of potassium iodide. Further, that interaction can be calculated from it is simplified by here. The break reflection of the non-molarity that is here. Actually, जब हम molar solution या molarity solution की बात करते हैं, ये point ये show कर रहा होता है कि हमारा ये solution 1 liter हो जाएगा. ये point. अब हम पहले solvent नहीं डालते, पहले हम क्या डालते हैं, solute डालते हैं. जैसे solute डालते हैं तो फिर सॉल्वेंट डालना शुरू कर देते हैं. सॉल्वेंट ऐसे ऐसे बढ़ता जाएगा जैसे इस लाइन तक जिसे हम मेनिस्कस कह रहे हैं, ये लाइन और उसके ऊपर ये मेनिस्कस बनी हुई है सॉल्वेंट के ड्यू टू सरफेस टेंशन. यहाँ तक ये पहुंचेगी तो हमारा जो सोल्यूशन है उसकी मोलैरिटी कंप्लीट हो जाएगी. तो इसलिए पहले सॉल्यूट डाल लेना है, पहले सॉल्वेंट नहीं डालना. तो ये जो सोल्यूशन होगा दैट शुड बी मोलैरिटी, मोलर सोल्यूशन. In case of molar solution, वहाँ पे हम पहले solute को ऐड नहीं करते हैं. पहले हमारा solvent जो है वो यहाँ पे आ जाता है. solvent हम 1 किलोग्राम पूरा कर लेते हैं. जैसे solvent 1 किलोग्राम पूरा हो जाएगा, फिर उसमें हम solute ऐड करते हैं और फिर हमारे पास solution की formation. Overall, the molarity of the solution remains constant, but with different methodology. So that is about molarity. Furthermore, dilution is a procedure for preparing a less concentrated In this category, two types of solutions are considered: stock solution and prepared solution. This two terms are used, and we can prepare the prepared solution from stock ones. So during this preparation, MI, that molar mass, molarity of the initial and the volume of the initial, that should be equal to molarity of the final and volume of the final. M1 V1 should be equal to M2 V2. So so we can prepare the molarity of the unknown components from the known. As mentioned here, how would you prepare a 60 ml of 0.2 molar solution, a stock solution from 5 molar HNO3? So M1 V1 should be equal to M2 V2, but it should be MI VI should be equal to MF and VF. So this one is the total VI that should be calculated as for V1 and M1, MF and VF. So 3 ml solution can be prepared. 3 ml acid, 7 ml of water should be equal to 60 ml of the solutions. And the next one is changing the molarity to molality and molality to molarity. We can convert it into different ways. As from moles are calculated, and from moles it should be find the molarity and molality. So different strategies are applied. That is mass of the solution, volume of solution, mass of solute, and mass of the solvent. So it can be developed to find from the molarity and molality as well. Further, what is the molarity of ethanol 5.86 molar ethanol solution? Whose density is this one? So from this one we can also find the molarity by using the density parameter and the other compositions, as that is the total solution. Mass of solvent is equal to mass of solution minus mass of the solute, and it should be 657 grams, or should be 0.657 kg. So mass and the moles of the alcohol is given, and the next one is total solvent. So from this molality can also be calculated. The molality should be equal to 8.92 molar. So these solutions are also applied for gravimetric analysis, and during gravimetric analysis, the perspiration of the components which are least soluble in the solvent. So the precipitate amount of the components can be weighed to measure the amount of that component. So ये जो हमारी titration techniques हैं, ये gravimetric analysis में हम apply करते हैं, और even हम acid bed analysis है, gravimetric analysis है, connectometric analysis है, redox titration है, ये सारे इसमें identification में आ जाते हैं, जैसे कि equivalence point है, indicator में, and the last one Friedrichs feature applied for titration against. Next question is what volume of the molar wonderful molar annual solution is required to titrate 25 ml of the 50 molar concentration of the H2SO4. So that's a equation H2SO4 and annual. And here's a calculation. So from this we can find that the volume of the solution should be equal to 158 milliliter. So volume can be calculated, mass can be calculated. That's also a solubility curves as well. Solubility curves actually these are affected by the temperature, as the increasing temperature solubility is also affected. End point equivalence दोनों के बराबर हो जाते हैं, और एंड पॉइंट पे जाके हमारा बिल्कुल हम स्टॉप कर देते हैं, वहाँ पे जाके एंड पॉइंट पे जाके हमारा रिएक्शन जो है या हम टाइट्रेशन को स्टॉप कर देते हैं. तो नेक्स्ट वन जो हमारे सॉल्वेटिव कर्व्स हैं, इसमें बताया जाता है कि हम सॉल्वेटिव कर्व्स को यूज करते हुए कैसे बता सकते हैं कौन सी कितनी अमाउंट है उसमें रिजॉल्व हो सकती है, ये भी बताए हुए हैं। और ये मोलैरिटी के सारा हमारे जो कैलकुलेशंस हैं कितने मोलर NaCl है और कितने मोलर हमारा उसको रिलीज होना चाहिए, तो वही फार्मूलाज हम इस पर अप्लाई कर रहे हैं। Molarity as well molality. So these are all our calculations in which income or volume is calculated, mass is calculated, and molarity is. Dilution, as we move from left to right, dilution is increased, and the dark red color of the solution that will fade into the light red color, so that is dilution. During dilution, more and more water is added for the dilution. As dilution and molarity is here, as we increase the dilution, the molarity of the solution is increased. मतलब हमारे solution उसमें मज़ीद अगर पानी डालते जाएंगे तो ओवरऑल उसकी नंबर ऑफ मोल्स पर यूनिट वॉल्यूम कम हो जाएगी, कंसंट्रेशन कम हो जाएगी। कैसे बढ़ा रखो? कंसंट्रेशन कम हो जाएगी तो उससे हम कहते हैं कि हमारी ओवरऑल जो डाइल्यूशन हो जाएगी। ठीक है, तो ये हमारा स्टॉक सॉल्यूशन और प्रिपेयर्ड सॉल्यूशन है, जो कि मैंने यहाँ पे बात की थी कि स्टॉक सॉल्यूशन एंड प्रिपेयर्ड सॉल्यूशन है M1V1 = M2V2, तो इस तरह से हम इसकी कैलकुलेशन करते हैं। ठीक है, और फर्दर इसमें जो आता है वो हमारा है स्टॉक वन कैलकुलेटर। मामा केड़ा सु स्टॉक म्यूट कर देते हैं ना। जी, ये हमारे जो है वो कन्वर्जन है M1V1 = M2V2, जिससे हम स्टॉक से प्रिपेयर्ड सॉल्यूशन प्रिपेयर कर सकते हैं। ये हमारी वेरिएशंस आ गई, ये कैलकुलेशंस आ गई और ये हमारा कवर हो गया। ये भी इस तरह की एग्जांपल है, हम स्टॉक से जो है वो प्रिपेयर्ड सॉल्यूशंस बना रहे होते हैं। M1V1 या MIBI = MFBF। So different examples are solved। ये मैं भी शेयर भी कर देता हूँ इस टाइप मोस्टली एग्जांपल्स भी दी हुई हैं और इसके साथ सॉल्व भी किया हुआ है। हमारे मोस्टली एग्जांपल्स में ये पॉसिबिलिटी क्या है, तो इसमें वो पॉसिबिलिटी ये है, फिर उसकी कैलकुलेशंस की। फर्दर है मैथ परसेंट हम निकालते हैं। मैथ से का वन कंपोनेंट डिवाइडेड बाय मैथ से कंपोनेंट मल्टीप्लाइड बाय, तो ये मैथ परसेंट आ जाते हैं। और इसमें W/W सॉल्यूशन हम करते हैं, W/V सॉल्यूशन करते हैं, V/W सॉल्यूशन करते हैं, and V/V solution भी करते हैं। So from this parameter mass percent is calculated in 100% में 100। ठीक है, इसमें W/W weight solution का मतलब ये है कि सॉल्यूट जो है उसको हम ग्राम्स में लेंगे और सॉल्यूशन भी हम उसमें ग्राम में लेंगे, सॉल्वेंट नहीं सॉल्यूशन। इवन W/V जब आएगा सॉल्यूट सॉलिड grams and the volume should be V volume. V. Example is given here. If the solution has 800 grams contain 20 grams of NaCl, so 800 divided by 220 divided by 800 multiplied by 100. So 2.50 percentage of NaCl can be calculated. There is another concentration, we can find the percentage as well. So mass over mass, 30 grams of NaBr. This is the calculations. Solutions with stoichiometry, that was the next one. There was a relationship between different components as mass, volume, moles, and the other components. These are also interconnected with each other. Reactants into products and products into reactants. Reactants moles can also be related to volume with grams, with atoms, and with molecules. And the products moles also can't be can be in liters, grams, molecules, atoms, and the further one molecules into atoms. Solution of first trichometry. How many moles of HCl are required to break with 30 grams of zinc? 13 grams of zinc is a very less amount. So if one mole of zinc is utilized, then 2 moles of HCl are required. But for this 13 grams, it should be 1 to 4 moles, and 1 4 moles, obviously, HCl should be 1 to 2 moles, and 1 to 2 moles uncalculated, so volume or mass is find it. Solution stoichiometry can also be calculated when we are going to compare the different solutions, by depending upon the units of measurements as well. So here is stoichiometry. Stoichiometry can be calculated to find out the final products and final solubility concepts. Solution stoichiometry that is also interconnected. H+4 and NaOH. So overall, we can find the NaOH are H+4. Mole fraction, as mentioned before, about moles of one component divided by number of moles of other components. Dilute solutions. That is a conversion between solution properties. So we can convert one parameter into other parameter by using both of the solvent, both of solute, molality, and mass fraction or mole fraction. And the mole fraction, these different are interconnected with each other. Different laws can be applied for the ideal solutions. As this one is the Rolle's law. Actually, P naught is the vapor pressure in prostate, and X is the mole fraction solvent. So that is the original and exact vapor pressure given. So Rolle's law is applicable for different solutions, and solutions which obey the Rolle's law, these should be the ideal solutions, and which doesn't, these are non-ideal solutions. So that is an aviation. If it is infracted above the line, it is positive deviation, and if it is below the line, that is a negative deviation. But want of equations can also affect the components, as dissociation of the solute to more particles, as delta V boiling elevation, boiling point elevation, delta F freezing point depression, and some other components. So want of equation can also affect this study. And the next one is Henry law. S is equal to Kp. S, actually that is the solubility of the gas, and P is the pressure applied. If more the pressure is applied, more gas will be soluble, and K is a constant just. And less the amount of solubility is applied, then less should be the solubility, lesser should be the concentration, lesser should be the partial pressure. Here are some colligative properties: elevation, boiling point, depression, freezing point, chlorine pressure, and osmotic pressure. So these are the colligative properties of the solution. When these components are added to the solvent, then boiling point is changed, melting point is changed, even vapor pressure, lowering of the pressure, that is also changed. So this is different constant of our temperature, our boiling point constant, and different temperature constant. So this is impacted here, and thank you very much. इक्वेशन जरूर नहीं याद कर लें, एक दफा देख लें, बस आइडिया हो गया कमांड ऑफ इक्वेशन कहाँ पे अप्लाई होती है, सिर्फ इतना देख लें कुछ और कमांड ऑफ इक्वेशन का ये बस पता होना चाहिए कि कहाँ पे किन से टेक्निक में किस लिए हम अप्लाई कर रहे हैं, तो जैसे हम सॉल्यूशन देख सकते हैं। The question is 1%.